Discover Geography, Lesson 2-5, Geographic Information Systems. A Geographic Information System, or GIS, is a computer system that can store, display, and analyze geographical information. Within a GIS, various pieces of geographical information are included as different layers. And one of the key functions of a GIS is that it can take all of these different layers, which may show very different types of information about the world, and it can coordinate them according to their location. It can basically line them up according to the location so that you can look across these different types of data shown in various data formats and examine what's going on between different aspects of the world. In your homework assignments, you're going to be looking at some online GIS systems where you can turn on and off different layers of data so that you can compare and see different things that are going on in the world. In this lesson, we want to talk about some of the different types of things that GIS can do, some of the different capabilities that GIS has today. So the simplest thing that GIS can do is it can show the locations of things. It can generate a map. So here you see a map of bushfires burning in Australia at a certain point in time when I grabbed this screen capture. The handy thing about doing this through a GIS rather than a static map is it can be easily and quickly updated. As fires start and go out, you can add them to the map and take them off the map very easily. GIS also allows you to change how that map is displayed. So here's one of those census maps that we've been looking at before. When you go on the census website to generate these maps, you have a lot of choices. You can change things like the choropleth category system. So you can take a map that was in an equal interval system and switch it to natural breaks and see what that does. You can change the number of categories. You can change it from 5 like I have here to 3 or to 10 so that you can change the way that data is displayed very easily and smoothly. Whereas if this was a static map, if this was just a paper map, for example, you couldn't change any of that. You couldn't see how that data would look different if you changed some of the settings on it. GIS also allows you to explore data in more detail. You can look at the map and you can drill down into certain aspects of it. You can zoom in on things of interest. You can click on things to get more detailed information. So here you see an example from the International Monetary Fund's website where you can display different data, economic data about certain countries, and then you can click on those countries to get more information. You can get data across time for those different countries, etc. GIS can also process data. It can take data that is showing one thing and infer from that data about something else. We mentioned this a little bit when talking about remote sensing. We showed those spectral profiles of different types of land cover. So we've got remote sensing data that's showing us the amount of light at various wavelengths, and we want to convert that into data about land cover, data that says this is this kind of forest, this is that kind of forest, this is barren land, this is water, etc. This is an example of that having been done to some data about a portion of the Middle East. What you see in kind of the center of the map there is the country of Iraq. So the GIS took some remote sensing data based on the wavelengths of different light that were coming through in each pixel, then figured out the different types of land cover that exist in this area, and so we created a new map with a different data set out of the old one. GIS can find routes between two places. It can figure out how to best navigate a landscape based on the information it has about roads, about the speed of travel across different areas, etc. So here is an example of using Google Maps, which I'm sure many of you have used Google Maps or a similar service to get from my old apartment to my office in Slippery Rock. GIS can also compare patterns between two different data sets. If you think there's some relationship between one thing and another thing, you can put them into a GIS to see if they really do correspond spatially. So here's an example from the 2008 Republican caucuses in Iowa. So this is one of the first stages of deciding who's going to be the presidential candidate. And the two leading candidates in Iowa that year were Mitt Romney and Mike Huckabee. And people started to wonder if these candidates' religion made a difference. Mitt Romney was a Mormon, which is a church that is viewed with suspicion by many conservative evangelicals who make up a large portion of the Republican voter base. Mike Huckabee had formerly been a Baptist minister. And so his style of speaking on the campaign trail was very similar to the way a preacher might speak in a church. And so if we look at these two maps, one shows which counties Romney won versus which counties Huckabee won. The other shows the percentage of Catholics versus Protestants. Most people in Iowa are either Catholic or Protestant, so the low Catholic areas are also the high Protestant areas. And so what we see is it looks, just from visually comparing these two, like Romney did better in areas that had more Catholics, Huckabee did better in areas that had more Protestants, because he was, of a similar kind of religious background to those folks. If we put these into a GIS and we compare the two spatial patterns, the GIS can confirm that that relationship does exist, that Romney did better in areas with fewer evangelical Protestants, Huckabee did better in areas with more evangelical Protestants. Another example, here are some information about whether toxic waste sites are located in neighborhoods that have high populations of people of color. So what we can do is we can take one data set about the demographics of an area, what race are the people living in those areas, and we can take another data set about the locations of toxic waste sites, and we can compare them. We can draw a little buffer around our toxic waste sites, draw a little neighborhood around it, and we can calculate the demographics of the area within that neighborhood close to the toxic waste site and the neighborhoods outside of that to see if there's a significant difference. And we can do that at various scales, so we can make that neighborhood bigger or smaller to see how that changes things. And we can look at sites all across the country to see if that pattern holds consistently across the country. And we'll be talking about this particular issue more later on in our class. And we'll see that, yes, there is a relationship, that those neighborhoods near toxic waste sites have a higher proportion of their population that's people of color than do areas farther from toxic waste sites. GIS can also help us select the best site for a particular thing. If we are trying to decide where to do something, so the example you have on your screen is where to graze livestock in the country of Australia. But you might be looking to, for example, find the best place to build a new Walmart. If you have a series of factors that make a site better or worse for this purpose, and you have data on the geographical location of those factors, what areas have those things and what areas don't, you can combine them in GIS to get an overall assessment of the best location for something. So in this case, the variety of factors that the person doing this analysis thought were things that would make an area better for grazing were things like soil fertility, rainfall, accessibility to roads. And these have all been combined so that that final map, the biggest one there, shows you the suitability of different areas for grazing. So if you're deciding where to graze your livestock, you can look at that map and say, okay, I want to go to this area or that area because that has the best total combination of factors that make it good for grazing. And finally, GIS can run models. If we have a mathematical model of some process that has a spatial element to it, some mathematical model that aims to analyze and predict where something's going to occur, we can use GIS to create that model and to run that model and to test that model. So this is an example from a model that was aiming to predict where deforestation would occur in a particular area of Massachusetts. And so the people that created this model took some data on where there was forests in 1985. Then they ran their model to see what their model predicted forests would be in 1991. And then they compared that outcome to the actual data from 1991 to see how accurate their model was. What areas did the model get right? What areas did the model get wrong? And what does that tell us about the usefulness of this model? Does this model accurately describe the processes leading to deforestation in this area of Massachusetts?